Hello everyone and welcome to Parametric Planet. Today I would like to show you how you can optimize your workflow using a Grasshopper Python component with a small example, and you can implement the same procedure on uh, other workflows also. So in this example, I have just created uh, a box, or you can say a rectangle. And with this script, what I'm doing, first I have created some points, and first a single point, then I move that point on the right side and on the left side. And then I have combined those points in this point component. And then I move those points or copy those points in Z direction so that I have 4 vertices. And then I have used this polyline component to make a closed rectangle. And then I have converted this one into BREP, or the boundary surface. We come here, and if we check this one, it's a BREP, and save in this component BREP. And then what I have done further, I have just calculated the area and find the centroid of this object. So if you see, it's a very not it's a long script, and if you have multiple objects, then you have to copy this one and again, and it will just make your script bigger, and it will be like a spaghetti monster, as it's called. It's very famous for nowadays. The people are using when you use too much wires and too much components, and they just mix with each other and creates a spaghetti monster. So there is a way you can create just one Grasshopper Python component, and you can extract all this information. So today I would like to show you how we can do that. So let's just insert our we're gonna model the same object, but using Grasshopper Python component. So I just insert our Grasshopper Python script, and the input I will give as, I will use the same inputs, width, and second one, depth. I will connect these wires here. This one, and this. Okay. So the first thing we will do, we will just create a origin point, a reference point. Let me just deactivate this script. Sorry. So, as you know, we can access this Rhino script. We have already imported Rhino script syntax at RS. So we will just say our origin point will be equal to RS to access Rhino dot. Then I would like to add a point. So I would just say add point. And then what it needs 3 points, or the coordinates X, Y, Z. So I will just write 0 to create at the origin 0, 0, 0. And if you test this one, now you cannot see because you have to output this name. So if I write origin, and now you can see here. So this is our first point. And now I would like to create a point on the right side, on the left side. So what I will do, I will just write OR, origin right, and we will use the same, so we will use the same command, rs dot add point, and then we will just, again, we have to give the coordinates. So in this one, I would use x as our width, but I would like to divide this into half. If it's 5, then the point on the right should be at 2.5 meter and the other on the 2.5, so that in total it should be 5 meter width. So I will just write here width divided by 2, and then y0 and z0. And similarly, I have to create the point on the left side. So I will just copy this one. I will just write minus here, and then I will write left. And I have to write these points here so that we can see OR. Well, so if you see, we have these points just with 2 command lines. Now I will just copy these 2 points so that I can create the points in the z direction. So I will, maybe it's better to bottom right, bottom left, and this should be now depth DH, and it should be minus because it's in the negative z direction. I will just copy this one, paste here, same here, and yeah. So now you can see all the 4 points in the Rhino viewport. So now we have to, we can also combine these points in the list so that we don't have to use so many outputs. We can just use one output. So if I just say points, and I will just make a list of these points. So OR, OL, BL, and BR. And I will just copy this one right here, and I will just remove this one. So now you can see your points are stored in this variable, and if you just, so you can look, it's a list. As you see the 2 wires, so it means it's a list of elements. So your all the points are stored here, and if you want to see the origin, it's going to be only a single element. So that's why it's a single wire. So now we would like to create a line out of these points. So let's say rectangle equal to, and now in the similar way, we can access the polyline component from Rhino script. So rs dot, we can say add polyline, and it requires list of points. So I can just this list here, and I have to write because I have to connect all these points. So this line will go from this point to this point, this point to this point, this point to this point, then again to this point. Then I have to add this point here. Should be OR. Point here, REC. We have unexpected token. So I forgot to put square brackets. So now you can see we have this polyline here. So till now we have wrote this part till here. So you see in here you have to use so many components, and in here you just write 2, 3, 4 lines in the script, and you can have your desired geometry. And now I would like to convert this one into BREP. So for that, we have to access this. In here, I have used boundary services. So it's a grasshopper component. So we have to access this grasshopper library. So I have to import grasshopper component. So for that, we will write this line import GhPython lib Python library as GHC. You can write any name here. So now if we just write BREP here, and we like to access this component GHC dot, what is this? Oh, GHC dot components, and if you again press dot, then it lists the components it has. So I would like to get boundary surfaces. Boundary surfaces. We have the boundary surfaces. And now I have to, I need aligns. So I will just use this one here. And I will add another variable here. I'll put BREP. So now we have this error data conversion failed from GUID to curve. So actually this command, this rectangular, give us the GUID ID, not the actual curve. So for that, Rhino suggests we have to use another command, which is Coercecurve. So for instance, if I change this one, store in another variable, CRV curve, and rs dot CO ER is equal to curve. If we go here, it will, yes, this one. So what it does, it's a basically method that converts your different representation of curves into other representation. For example, now it's a GUID, so it's GUID, it will convert into actual curve. So actually, they are basically there to help the code to use different software design kits. So in Rhino geometry curve class. This is another subclass for curves. So we can just use this one, and then I have to pass this curves, this GUID which we have created. And now when we use curve here, which is the converted one, then it will not give us any warning or the error. So you see, now it works. So it's very important whenever you have this error for the curve, just use this class or this method, CoerceCurve. So then it will convert your GUID into actual curve. It's basically a type of representation. So now we have developed our script till here. So now I would like to access the area and the centroid of my object. So for that, it's again, I have to access the area component of the grasshopper. And if I say area equal to GHC dot again components and dot area, and I have to provide the brep. So or we can just directly provide our curve. And if you see here, area. So it actually provides us the area and the centroid. So now if we just use this panel, so it will give us the area, which is 25. And at the same time, it gives us the centroid of the rectangle. So if I just want to extract this point, I can just write here another variable centroid, and look in the list, it's the second element. So I can just access this element using this slicing method in Python indexing. So it's at index 1. And if I just create here another output variable, centroid, enter, and now it's a point. So if I just click this one, you see, that's the point. So this large script is converted into only single component. So you can save this component, and whenever you want to create this rectangle, you can just use this component. You will have the points, it will give you the edges, the lines, it will directly give you the brep representation, boundary representation, and it will give you the area, and it will give you the centroid. And if you just change this one, the values will automatically change, so you don't have to worry. So if we check the time, it takes 16 milliseconds to run. Another thing you can do, you can convert this whole script into cluster. So this is how you can use Grasshopper Python script to optimize your script. And if you are working with a large number of components, so I think this is the best way you can optimize your workflow, and you can save a lot of time in the future if you just directly save this one or make change into cluster and create your own component tab here and put all the cluster, all the components there. So I hope This video will help you to create your scripts, and I hope you like this video. And in the next video, I will show you some other tricks and some other methods to Grasshopper Python script. Good luck with your Grasshopper. And thank you very much for watching this video. Bye-bye.